Hey, this is 8th grade lesson 4.1. It's actually part 2. Our objective today, students will review input and output patterns and use this knowledge to solve board problems that involve a function. The standard covered again is 8F1 as well as 8F2. The page numbers say you'll be working, so these are in your hardcover book, but we'll actually just be doing them together. So that's out of page 147 through 153. Okay, today we're just going to be working with some word problems. Yesterday, or previously you worked with a function. Remember, function form is when you have a y equals format. You have your domain, which is also known as your x values or your input values. You also have your ranges, which are your y values or your output values. So we're going to go through and actually just solve some different word problems using some of this information as well as a table. So it says the table shows the percent y in decimal form of the moon that was visible at midnight X days after January 24th, 2011. Interpret the domain and the range. So if we interpret it, we're just basically telling what is the domain? What do those numbers in the domain mean? So our domain is our X's, right? These are our domains. These are our ranges. So our domain are our zeros, ones, twos, threes, and fours. So here, because they're asking us to interpret that, they don't want us to just list 0, 1, 2, 3, 4. They want us to tell what those are. What are those X values representing? Well, they're representing the number of days after January 21st. So our domain is the number of days after January 24th. Okay. Our ranges then, if they ask us to interpret the range, they're not asking us to just say it's 0.76, 0.65, 0.54. They want us to tell what do those numbers represent. Well, our range is representing our percent of the moon that was visible at midnight. Okay, so that's interpreting it, not just saying what they are or identifying them, but interpreting and understanding what those numbers mean. Letter B says, what percent of the moon was visible on January 26th? So if this started on January 24th, then that means that this date right here is the 24th at 0. One day after that, that's what our X was, the number of days after January 24th, that means that this is the 25th. So then that means that this here is January 26th. So it says what percent of the moon was visible on January 26th? Well, that was 0.54, which is what percent? 54%. Okay, so that's working with a story problem where they're giving us some information as to what those numbers are actually representing, and then piecing that together into a real world scenario and understanding that information. Okay, so we're going to go ahead and do another one of these. Okay, so here's our next one. Okay, so it says the number of earrings and headbands that you can buy with $24, so we only have $24 to spend, is represented by the equation 8x, which were earrings, plus 4y, which was headbands, equals 24. So how do I know those? I'm looking at the table as I'm reading it and seeing that my X was representing my earrings and my Y was representing my headbands. That's how I knew what those meant, okay? So it says the table shows the number of earrings and headbands that we could purchase for $24. First thing is to write an equation in function form. So remember, function form is when we get it into that Y equals format. Okay, so right now we have 8x plus 4y equals 24. We have to work to get y all by itself. So we're going to leave that there for right now. So our first step would be to do minus 8x and minus 8x. Okay, now we want to get y by itself. So right now it's 4 times y. So we're going to divide by 4 to get rid of the 4 off that. And we're going to do that to each of these. Okay, so I'm going to go ahead and write it with the X first, just in case I wanted to graph this later. And I could graph it without filling in the table. So we have y equals, we should always put our X first. So remember that negative is going with this. So if I reduce that down, 8 divided by 4 is 2. So it's a negative 2x. And then 24 divided by 4 gives me 6, and that would be a positive 6. So there's my equation. find the domain and range. So right now, what I'm going to do just to save time, I'm going to go ahead and just mark my domains and ranges on this table that I have up here on the screen. So my domains are my X's. These are my domains. My ranges are my Y's or my outputs. So this is my range. Letter C says Y is X equals 6, not in the domain of the function. So if we were to continue this pattern, why can we not have 6 earrings? Okay, so remember, we didn't ever figure out how much the earrings were, but by understanding what this means, it means we spent $8 for each set of earrings. So if we did 8 times 6, that would give us $48. We only had 24 to spend. So why is that not in there? Because we don't have enough money. Not only that, we could not have a negative number of headbands. Okay, so either of those were to work. That double mark there means can't have a negative number of headbands. Okay, so that's understanding that in the real world, if you were to have one of these equations, you have to understand what those numbers represent. Okay, they're no longer just numbers, they're representing a real scenario. And in this case, we can't buy 6 pairs of earrings because 1, we don't have enough money. And 2, if we have a limited number of money to spend, we can't end up with a negative number of objects, such as headbands. Okay, so let's go ahead and do one more of these, and then I'm going to have you guys do one independently. Okay, so here we've got a manatee eats about 12% of its own body weight each day. Write an equation in function form that represents the amount Y in pounds of food that a manatee eats each day for its weight X. So we want to figure out how many pounds our Y equals. So we want to figure out how many pounds of food we're going to have to feed that manatee if it weighed so many pounds. So Y equals 12%. So I'm going to write that out as 0.12 of its weight X. Here's our equation. Now you could write 12%, but you have to understand that when you go to do this, you actually have to use 0.12. Okay, so letter B, I'm going to go ahead and write down below. So letter B says create an input-output table for the equation in part A. So here's our input-output, and they're giving us certain pounds that they want us to use. Okay, so they want us to use 150 pounds. These are my X's or my inputs, my Y's, which are my outputs. And then 300, 450, 600, 750, and then our last one is 900. Okay, so now we're going to go ahead and do our output. So when I do this on my calculator, I am going to punch in on my calculator this equation, 0.12 times, and then whatever my X is. So the first one that I'm going to do is 150. So when I punch in 0.12 times 150, it should give me 18, and it does. So it's going to require 18 pounds of food for that manatee for that one day. Okay, if I had a 300-pound manatee, I would do 0.12 times 300. So a 300-pound manatee would require 36 pounds of food. Okay, so a 450-pound manatee is going to require 54 pounds of food. And you can see that they've given us a pattern where they're increasing the weight of the manatee 150 pounds each time, which is 18 pounds of food each time. Okay, that doesn't mean that our table would always be that way. That's just the way that they gave us for the inputs, the numbers that they gave us. So my next number would be 72 pounds here, 12% of 600. Then I would have 90 pounds, 12% times 750 would be 90. And then 12% of 900 is 108 pounds. Okay, so letter C says find the domain and range of the function. So I'm just going to mark these in red. My domains are my inputs. My ranges are my outputs. So once again, working that vocabulary and just understanding the difference between those. Letter D says an aquatic center has manatees that weigh 300 pounds, 750 pounds, and 1,050 pounds. So we have 2 of those there, but we don't have the third one. How many pounds of food do all 3 manatees eat in a day and then also in a week? So there's a couple different ways that we can solve this. We could extend our table out to see what the 1,050 pounds would be, and then we could add all 3 of them together. Or we can just add all 3 of these together. Okay, so if I do 300 plus my 750 plus my 1,050, it's going to give me 2,100 pounds. Okay, that's the weight of my manatees. Now, I'm going to substitute that in to that part of the equation. So I'm going to take that times 0.12. And that is 252 pounds. That's per day, okay? Now, they want to know also how much it would be per week. So if I know that it's going to be 252 pounds in a day, well, there's 7 days in a week, so I'm going to go times 7, which is going to give me 1,764 pounds of food per week that we have to feed those manatees. Okay, so that's using real world and an equation, an input-output table, and understanding, okay, what that's actually representing. Okay, so I want you to go ahead and try this one independently. Okay, it says the table shows the percent Y in decimal form of the moon that was visible at midnight, X days after December 17th. So that means that this is December 17th. Okay. Interpret the domain and range. So when it says interpret, it doesn't mean tell me the numbers. It means what do those numbers represent? So what does 0, 1, 2, 3, 4 represent? What are those? What are the X's representing? And then what are those Y's? What's the 0.2, 0.3, 0.4, 0.5, 0.6? What are those representing? Okay. Then letter B, you're going to have to use the fact that 0 day is December 17th to find out what December 21st percentage would be. So go ahead, pause your video and work your way through this one. Okay, so your domain was representing the number of days after December 17th. Your range was representing the percent of the moon that was visible. And then letter B says what percent of the moon was visible on December 21st. So I extended out my calendar and noticed it was 0.6, which is the same as 60%. Okay, so that's it for this part of the lesson, just mainly focusing on those domains and ranges and understanding that those numbers really are representing true numbers in a real world scenario. Good luck with this.